Okay, hope our last session was informative and hope all the questions have been dealt with sufficiently. What I'd like to look at going forward is the what? Is the binary subtraction. Let's say binary subtraction. Okay, so remember number of combinations is still given by 2 to the power of n. So if we're going to subtract and we are going to follow the count, we're going to subtract, we're going to follow the count 0, so 0 minus 0. In this case, we've got 4, so it's going to be 3 combinations. The count 0 to 3. So 1, 0 minus 1, 2, 1 minus 0, and ultimately 1 minus 1. Alright, this is obviously very easy. 0, that is easy. 1, that is easy, it's 0. Okay, this is how we've traditionally done all our easy commutations like that. If you look at 0 minus 0, 1 minus 0, those are traditional. 1 minus 1, those are traditional and easy answers. Now there lies in the little problem. Let me take a scenario where I say I'm gonna illustrate this with what? With decimal. I'm gonna say if we have 29, okay, no, 293 minus 79. Let's say we're separating numbers like that. What do? We try to say, can 3 take out 9? We say, no, it can't. What do? We come to the 9. This is tens. We borrow 1 10. We remain with 8 tens. Then we take that 10, we bring it here. Do we write a 10 here to show we borrowed a 10? No. We just write a 1. We just write a 1. We don't write a 10. We write a 1. And we know that 1 means a 10. So we say 13 now. We don't say 4. So we didn't borrow 1. We borrowed one set of the base. Now we are coming back to what? To this issue of carrying and subtracting. We can carrying and what? And borrowing. When we are carrying a what? A set of the base. And in as much when we what? When we borrow a set of what? A set of the base. So we borrowed 10, not 1, because if we borrowed 1, this was going to be 4. We're still going to have a problem. So we borrowed 10, that's why we come and say 10 and 3 is 13. So we say 13 minus 9, and we say that's what? That's 4. Because we what? Because we borrowed a base. This is base. Okay, we borrowed a base. So we then say, now we have an 8 there. We say 8 minus what? 8 minus 7 is obviously 1. And then this is what? This is our 2. Now, obviously, 214 plus 79 is obviously going to be what? So it's going to 214 plus, plus 70 or plus 80. It's going to be 294. But this was 79. So you subtract 1, 293. So it's straightforward. What I wanted to highlight and emphasize here was what? The borrowing. What are we borrowing? We are actually borrowing a base. Let's have another example. We say 900 and what? 904 minus 67, 367. What do? We say 4 cannot take out 7. We try and, there's nothing to borrow from. What do? It's not a train smash. We come and borrow from here. We borrow 100, so we remain with 800. But when we borrowed, we took one of the what? One of the hundreds, and we brought it here. If we put it here, it becomes now 10 tens, because it's 100 that we took there. So yes, it's 10 tens. So when we've got 10 tens, we don't come and say we borrowed a 10 here. No. We just write a 1. We know it's 10 tens now. Now we can borrow from these 10 tens and remain with the what? With a 9. What did we borrow? We borrow a 10 this side. So yes, 10 plus 90 is the 100 we borrowed from here. So we don't come and say 5, so we didn't borrow 1. We actually borrowed a what? A 10 from the what? From these 10 tens. We borrowed from the what? From that side there. So what is this here? This here becomes 14 because 10 and 4 becomes 14. 14 minus 7 then gives us what? We are subtracting. 14 minus 7 gives us a 7. Now with 9 can subtract 6 and we're happy, it's a 3. And 8 can subtract a 3 and give us a what? A 5. And I'm sure when you go back, 7 plus 7 will be 14, which is 4. Carry 1. 6 plus 3 plus that 1 gives us 10. Carry 1. 3 plus 5 will be 8, plus that 1 becomes 9, and we are all happy. The whole point is, what I'm trying to illustrate is, we borrowed from here, we borrowed what looks like a 1. We didn't borrow 1, we put a 1 here, but it was a whole 100. This is a 100 column, so we borrowed a whole 100. But a 100 under 10s is actually just 10 tens, so this is 10, so we can borrow now from this. We've got something to borrow from both. We borrow to the immediate what? To the immediate right. So when you borrow here, we have what? 1 less 10. So we have 9 tens left. And then when you borrow, we took a 10 from here. So that 10 came here and added to this 4 and gave us a 14. I think it's very, very easy. I think it's very straightforward. So I wonder where the confusion comes from. So now, when we do the same thing in binary, when you come to binary and say, okay, what about in binary now? We want to say 1001 minus 111. This is obviously 9 minus 7. So let's see. This is easy. It happens very easy. We know 1 minus 1 is what? Is 0. So this is easy. Now 0 minus 1 gives us that problem again. What do we do? There's nothing to borrow from here, so we come here. What are we borrowing here? With respect to this, we are actually borrowing in what? Borrowing in because from here we're actually borrowing there. So what we cannot immediately come here. What do? We go to the immediate right. What do we borrow? We borrow that is borrowed there. But remember, with regards to this, we have borrowed something that is 2 times bigger. These are the 4s, these are an 8, so we borrowed something that is 2 times bigger. So we actually borrowed the 2. We borrowed the base again. Now we say 1, the same way we said 1 0 here was 10, 1 0 here under binary, this is 2. Now 2 can subtract 1 now. So we've got 2 here. When we borrow from this 2 now, because we need to borrow here, when we borrow from this 2 now here, we remain again with 1. We borrowed from the 2. Now what do we have here? We've got 2. So that out of the 2, we borrowed 1. So that 1 is 1 set of the base. So now we say 2. The same way we came and said, now we say 13 because we took a 10. Now we are saying 2 here, not 1. We didn't borrow 1. We borrowed 1 set of the base. Now we come here and say 2. So we say now 2 minus 1 is a 1. Okay, so that is now 1 because when we took away a set, then gave it there, we were left with 1 set left. So it's 1 set minus 1 set, that is 0. And that when you borrowed here, nothing remained here, 0. So we know this is 2. Our 9 minus 7 is obviously 2. Now this thing of putting that 1 there can be confusing because people can start thinking of what? Thinking of 10. This is not base what? This is not base 10, this is base 2. So 1 0 in base 2 is actually what? Is actually 2. So if I did another example, let me say I probably say 1 1 0 0 1 comma 0 0 1, and you're subtracting 1 1 1 comma, and then you say what? We say 1 1 1. We know obviously this is a bigger number. It's got what? A lot more. So this is what? This is a higher order for 2. So we know this is a bigger number. So we say let's subtract that, and you say 1 minus 1 makes our life very easy. It's a 0, and we put our 0. Remember the little 2 because sometimes we forget it and our answer becomes wrong. Now we have nothing here. What do? We come here and we borrow from here. When we borrow here, we're actually borrowing to this space. We have got 2 here now. This is a 2 now. 1 0 is a 2. Now I borrow 1 from this and I'm left with a 1. Okay. Now, what have I borrowed? I borrowed 1 set from 2 sets. So I've got 1 set left here, but I've got what? The other set promoted there. So I actually borrowed the base 2. That's why I'm now able to say 2 here. Now 2 minus 1 is a 1. Okay. Now 2 minus 1 is a 1. Now 1 minus 1 is a 0. And then This is now 0, so it means we have to borrow where we can only borrow from here. We borrow that set immediately to the what, to its right. Now that is now a 2, so we borrowed a base, because we are now saying 2, we're not saying 1, so we borrowed a base. This is now 2 we are going to borrow there, so we are left with 1. We borrow one set, we borrow it immediately to the right, and this is now a 2. 1 0 is a 2. We say, okay, borrow us now, because we want to borrow there. We say you are going to be left with 1, and our 2 is going to be 0. It's going to be on this 0, because when you took away here, this was a 0 left, so this is going to be actually a 2 here. So I don't know now whether I should now put a 0 here, 1 0 up there, to remind us I have borrowed 2, so I borrowed a base. You see, now if I say 2, my life goes easy. If I say I borrowed 1 here, I have to say 1 minus 1, which is obviously going to be wrong. So I'm saying 2 minus 1 now, and my answer is 1. Now 1 minus 1 is obviously going to be a 0. The other 1 minus 1 is going to be a 0. When we borrowed from here, we had nothing left. Then our 1 here is subtracting nothing, and we are happy. That is our answer there. I'm trying to take it as slow as possible, because it's a little bit, I think it's a little bit, this one's a little bit confusing. Now, what am I saying here? I'm saying when we come here, if I look at a scenario, let me take a simple scenario. Let's say I've got 1 0 and I'm subtracting 1. This is obviously 2 minus 1. This is all in binary, so I could not do it, so I come and borrow a set from here. When I borrow a set, I've got nothing left here, but I've got 1. I've got this 1 here to make this a 2. Now I've borrowed a set, one set of what? Of 2 to make this a 2. So this is 2 minus 1, and our answer is 1. Obviously 2 minus 1 is 1, and that's true. So what is our answer here? 0 minus 1. The answer is 1. Oh, I don't like my numbers being bad like that. So the answer is 1. Why is, I think probably my instruments are not setting properly. I will try again. My answer is 1, but because I borrowed 1. Last time we carried, this time we borrowed. So I borrowed what? I borrowed 1 set. Oh, I wrote the full carry, so I think it's only fair to write 1 because I borrowed, because I had to borrow 1 borrowed 1. But what I guess here, set of the base, because we saw when we borrow that 1, we then will say 2 minus, we didn't say 1 minus, so 1 set of the base. Okay, so it's a little bit, I don't know if it's difficult, but I think it's the only confusion here is, I don't know why people really get confused. When we borrow and we say, here we now sound like we borrowed a full set of things. I mean, I'm talking about in a scenario like what? Of decimal, where we borrow and then we don't say the next number, we don't add 1 to the digit that we're borrowing to, we now add a 10, because when you say 14 here now, we didn't borrow 1. If it was 1, it would have been a 5. I don't know why it will be confusing in the case of 2, because we borrowed a set of 10, that's why we're saying 14. We borrowed a set of what? Of 2, that's why we're saying 2 now. 1 0 is 2. I borrowed a set, this is 2 times more than that. Every number in a column to the what? Every number to the left is 2 times bigger than the what? 2 times bigger than the what? The number immediately to the right, the digit immediately to the right. So if you look at, I mean, the weight of it, the weight here is 1, the weight here is 2. So a number here, the number immediately to the left is what? Is a weight 2 times the what? That one there to the right. So if in here this is the what? The weight of 4. So this weight of 4 is 2 times the weight of what? Of that one there. So you can see that this one is 8. Same story here. This would have been 16, 32, and so on and so forth. So when we borrow, we are borrowing from the one on the what? From the one immediately to the one to the immediately to the what? To the left. Therefore, when you borrow to the right hand side, we are borrowing something that is 2 times. So if you take 1, we're taking actually 2, because it's what is 2 times. It's got 2 times the what? The weight of what where we're borrowing 2. So I think that is not as complicated as it turns out to be when people are getting all confused. So I hope this helps. I hope I can now say we can do a few examples with what with our binary subtraction. Let me go and probably start a new page and say, okay, let's try this again and say, all right, a few examples. I've already done a couple, but just to make this stick, examples. Let's say we do examples 1, 2, 3, 4, 5. Okay, the first example, I'll make it simple. 101, comma 01, comma 025 in base 2 minus, let's say 10. Okay, let me not say 10, let me say 10, comma 1. This is 2, comma 5 base 2. Let's say the next example is 1, 1, 0, comma 1, 1 minus 1, 1, comma 1, 0, 1, and again it's base 2. Let's say I say 1, 1, 0, 1, comma 0, 1, 1 base 2 minus 1, 0. Then I say 1, 0, comma 1, 1, 1 base 2. Then I say 1, 0, 0, 1, comma 1 base 2 minus 1, 1, 0, comma 1, 1 base 2. Then finally I say 1, 0, 1, 1, comma 1 base 2 minus 1, 0. All right, so those are the 5 examples. Let's take I would suggest at this point that people pause the video and go on to and go on and try these examples for by themselves, and then we can come and when I'm helping you, when I'm answering this, it will look like I'm actually correcting whatever you have your effort would have been. So let's take the first example, example 1, and we say it is 1, 0, 1, comma 0, 1, and it's base 2, and it's minus 1, 0, comma 1, and the standard is balance up your digits first. Okay, so this here is what this, remember we did this in what we did this in when you're doing addition, that when we put up our zeros here, the zeros after the comma will not affect the value. The zeros before the whole number will not affect the value of of the number. So we haven't done anything. We haven't actually set up our own question. Now if you now try to look at this column here, it's a 1 minus 0, and our answer is obviously 1. 0 minus 1, we have to say it's 1, because I'm following the rules now, because I borrowed from that one there. Okay, so it's 2 minus 1 actually. All right, so now when you borrow and there's nothing left, 0 minus 0 will be 0. Let's keenly remember that our comma is staying in its position. So now 0 minus 0 will be 0, and then 1, again we have the same situation here where we have to go and borrow. We borrow one set, so it's now called 2. 1, 0 is a 2. 2 minus 1 is a 1. So there is our answer there. I don't think that was difficult. I hope now if you did your part and you try to do this on your own, you are seeing now how easy this is in case you made a mistake. Now let's go to the next one. It's 1, 1, 1, 0, comma 1, 1, and then is base 2. I meant to say base 2 here. I did not do that on purpose. I meant to say base 2 there. So because if I have to go into changing this number into binary here, these ones here, we're gonna do this forever. So let's just put the little 2. I would have left it and say let's do it as it is, but I can foresee trouble here. It will go on forever. Now 1, 1, 1, 1, comma 1, 0, 1. Now I suggest that I must remove this 2 here and first put up a 0 here to balance up my digits, only because there's a comma there. All right, and then I balance up my digits, and then I balance up my digits. This is the little putting my base here, so I subtract. I don't like that. I don't like that, so I'll say try to be, yeah, that's better. We can't do it here, so we come and borrow there. That becomes a 1, 0, which is a 2. 2 minus 1 is a 1. Okay, this is a 0 now. 0 minus 0 is a 0. 1 minus 1 is a 0. And then comma. We can't, so we come and borrow there. This becomes 1, 0, which is a 2. 2 minus 1 is a 1. And then there's nothing here, so we can't do that. So we come and borrow here, and we need this to be a 2. So 2 minus 1, because we borrowed a set, so it's 2. 2 minus 1 is going to be 1. But that was a 0 left, so 0 minus 0 is going to be 0. And then 1 minus 0 is going to be 1. Okay. I hope so far you're happy. I hope that forgetting the little 2 there didn't throw you off. It actually defeats a little purpose. I'll come to mention it. It defeats what I was trying to do. That little mistake cost me a little because I wanted to catch you out on. I wanted to catch you out on being awake, and then I'm caught sleeping myself. It's a little bit embarrassing actually. Let's go to the third example anyway. Can't be embarrassed forever. 1, 1, 0, 1, comma 0, 1, 1, and this is base 2, and I'm trying to get out to subtract 1, 0, comma 1, 1, 1, and base 2. And first thing I'll do is balance up my digits. And what do we have now? We have 1 minus 1, 0. I immediately put my 2. 1 minus 1 again, 0. But here we have a problem, so we come and borrow here. It's immediately what? Going to be a 2 here. 2 minus 1 is going to be a 1. And then we have our comma in its position. 0 minus 0 is going to be 0. Now this here, I have to go and borrow, and it becomes a 2. 1, 0 becomes 2. 2 minus 1, it's a 1. Then this 0 minus 0, it's a 0. This 1 minus 0, it's a 1. And that was our third situation. Our number 4 is 9,5, 1, 0, 0, 1, comma 1, base 2, minus 6, 1, 1, 0, 6, comma 7, 5, 1, 1. Okay, now I am forced to come and say I cannot have the little 2 there. Why? I want to balance up my digits and put my 2 there, put my 2 there, subtract, balance up my digits, and now I can subtract. I can't do that, so I come and borrow. This becomes a 0, and now this here becomes, because I borrow, this becomes a 0. Now the 1 comes here, but it's a 1 set of 2. This makes this a 2. 2, 1, 0 is a 2. 2 minus 1 is a 1. Now I have a 0 there. I can't take out 1, so I come and borrow here. This remains 0. And then what happens here? I brought a 1 set of 2. This makes this 1, 0. This becomes 2. 2 minus 1 is a 1, comma 0 minus 0. We are happy. Then I can't do this. I come and borrow where I can, but I'm gonna borrow there, and this is one set. Immediately to the right, it's one set. This column is what? Is twice as big as that. So when I take one here, I'm taking something twice as big. So this is one set of 2. This becomes 2 minus 1. Leaves me with a 1. Okay. Now, no, I'm saying 2 minus 1. I don't mean this one. I mean the one that I'm borrowing here, because I'm gonna borrow one set there so that I'm able to do this part here. Probably saying 2 minus 1 might have confused people that I'm doing this part. No. I had 2 here because after borrowing here, I've got a 2 here. This 2 here, when I borrow, is 2 minus 1 that I got. This one that is left here, there is my what? My one that I had borrowed is actually come here. This is 2 minus 1, and we get ourselves a 1. Let me make that a little bit. Okay, 1. Then we had 1 left there after taking away 1 to this side. We had 1 left there. 1 minus 1 is a 0. And we took away that, so 0 minus 0 gives us 0. So this is what? This was 9,5 minus 6,75. Our answer is obviously 2,75. Okay, 6 and 2 will give us 8. 0.75 and 0.75 will give us 1.5. 8 and 1 will give us 9, and then it's 9,5 with that of 0.5. Now let's do the last one. This is where I felt the purpose of my exercise was a little bit defeated by a little recklessness, a little carelessness. So now it sort of now people will feel they were justified to misread number 5. Number 5 was purposely set as it is. There was no mistake in number 5. The question was 1, 0, 1, 1, comma 1 minus 10. This was a 10. I put this up to catch people on what? On being awake. But now that I made a little mistake myself there, now it looks like these people are now justified to have what? To have assumed this was what? This was also a mistake. Actually, no. This was a misprint. This was intent. I intended to make it 10 there so that people are aware that we're not subtracting 2 here. We are actually subtracting what? We are actually subtracting a whole 10. Our questions, we must be careful. Our questions can be set in such a manner that they want to catch you on being awake. Paying attention is part of what? Is part of schoolwork. So what we'll do is we'll first say what is, we will first have, because we will first have to appreciate that that number there is actually decimal. So we'll first have to convert it to binary. 2 into 10 would have been 5, remainder 0. 2 into 5 would have been 2, remainder 1. 2 into 2 would have been 1, remainder 0, and 2 into 1 would have given us 0, remainder 1. So we are dividing, so we put our lines. All right, so we take our answer up, and if we do that, our answer then becomes, so we were not subtracting 10 there, we are actually subtracting what? We're not subtracting 2 there, which would, it would have been 2 with a little what? With a little 2. I intend, as opposed to what I did there, which was being careless and being forgetful, I intended to make that a 10. So when you subtract here, you're actually subtracting 1, 0, 1, 0. It's done on purpose sometimes in what? In a test or exam to what? To catch you on what? On being attentive. So be very attentive and look out for such what? For such deceptive, what you call this, tendencies by people, let me say assessors. Okay, assessors sometimes can purposely want to catch if you are the kind of student that pays attention. So this would have been, to balance up the digits, this is a 0.0. So there we do our maths. 1 minus 0 is a 1. Our comma stays there. Let's not forget the little 2. 1 minus 0 is a 1, and then you can see the rest is the same. So therefore our answer would have been, so this was basically 11,5 minus 10, which is 1,5. All right, so remember that was intent. Sometimes we purposefully watch out for things like this. All right, when you are doing your your binary addition, sometimes numbers are mixed. I can ask you to what? I can ask you to do for me to subtract for me, I can give you numbers. Let me give you another example. Let's say I can give you numbers like, let's say I say subtract, and I say, what are you subtracting? I can say subtract 27, which is a decimal number obviously, minus 7 8, which is a what? An 7 8. Let me do that. I didn't intend to. There's no 8 in what in octal, so I want to remove this here and make it 7 2 in octal. My point is to show you that it's possible that we mix numbers on purpose, and then we say do this in what? In binary. I can say in binary. Okay, and I can say give your answer, and I can say in hexadecimal. So assessors have the right to try and what, and play around and see if students actually know the answer. I don't need to be very direct and say, okay, you know what, convert this to hexadecimal. I can combine my my arithmetic with my conversion in my question, and it shouldn't be something extraordinary, because you can see how simple it is. We have to convert this because we have to do this in binary, so we have to convert this to binary. So we can say what is 27 in binary? We say 27, we divide that, and we say 27 is divided by 2 is 13, remainder 1. 2 into 13 is 6, remainder 1. Why do I like 27 so much? I've been doing this 27 forever. Maybe it's because it's my birthday or something. It's always in my head or something. I don't know. This is 3, remainder 0. 2 there. That will be 1, remainder 1. 2 there is 0, remainder 1. And you take it up. Okay. And you say, okay, what actually 27 is actually what? 27 is equal to 1011. Oh, there are 2. I made a mistake there. I omitted the 1. It's 11011 base 2. Then you say, okay, what about 72? 72 is 72 base 8 is 7 times 8 to the power of what? To the power of 1 plus 2 times 8 to the power of 0. Together they give us what? 7 times 8 is 56. Already have a bigger number here, do I? Don't I? I thought I was hoping that, okay, I wasn't paying attention. This is going to be what? 56. This is going to be 56 plus 2, which is equal to 58. Okay, now say, what is then 58 minus what? 58 minus, in binary, I'll say, what is 58 in binary? I'll say, okay, therefore 7 2 base 8 is equal to, and then we're saying it's actually 58, so we have to check 58, not 50. The 2 there is going to be giving us 2, because it's 9, the remainder of 0. 2 there is going to be giving us 14, it's going to be giving us 14, remainder 1. 2 there is going to be giving us 7, remainder what? Remainder 0. 2 there is going to be, my spirit is low now because I didn't pay attention. And then 3, and then we are gonna have 1, remainder 1. 2 there will be 0, remainder, okay, 1. Now my speed is a little low, so this is equal to 1 1 1 1 0 1 0. Okay, in base 2. Now we know that okay, my intent was to have a bigger number, but it also serves a purpose. Okay, every time, you know what, you can always when life gives you lemons, what do? You make lemonade, right? So I intended to have 27 subtract a smaller number. I wasn't paying attention, I just threw numbers there. It turns out I'm trying to subtract a bigger number, but we know that actually 27, we do know that, by the way, therefore A minus B is equal to C, and C is negative less than 0 if B is equal to what? Is equal to, if B, I say if B and I write an 8, if B is greater than A. What am I saying? I know that if it's 2 minus 3 is actually minus what call this 3 minus 2. So therefore I can say, all right, my answer here is going to be 1 1 1 0 1 0. This is what? This is 72 verse 8, yeah? Minus 1 1 0 1 1. This is what? 27, and our answer here is, I want to balance up my, because I've said this is a standard that people must have this habit, minus. So this here is, this answer that we're going to get here is what? Is it's going to be negative for 27 minus 72, because 72 minus 27, the answer is going to be what? The negative of 27 minus what? Minus 52. So our answer here is what? Is, we can't do that, so we come and borrow. This becomes a 0, but that 1 comes there and makes it a 2. 2 minus 1 is a 1. We put a little 2. Then this is now a 0, so it can't take out that 1. We come and borrow, and this becomes a 0. We borrow, that becomes a what? A 2. We borrow again, this becomes a 1 because we've borrowed there. Now we've got 2 minus 1, that is a 1. 1 minus 0 now becomes a what? A 1 again. And then this is 0. We come and borrow from there. And when we borrow, we have nothing left because we borrowed that set there. So we took 1, but that 1 made this a 2 because we borrow a set. So we borrowed 2. 2 minus 1 is a 1. And then I come and borrow from here, and I borrow a set. This becomes 2. 2 minus 1 is a 1. So that is our what? Our final answer. But this is 72 minus what? Minus 27. Therefore, no, 7 2 plus 8 minus what? Minus 27. Our question was, therefore, 27 minus 7 2 to base 8 is actually the negative 1 1 1 1 1 base 2, because the smaller number separating a bigger number, the answer has to be negative. So we should know this, even though it was a mistake, but maybe it also we can actually exploit that mistake and take advantage of it. So I hope this was a little bit useful. What I want you to be aware of is that you can be asked to deal with numbers in different bases, and then be asked to do that calculation in binary, and then give your answer in something else. So we are not done here, because our answer is supposed to be what? Our answer is supposed to be our answer is supposed to be in hexadecimal. So we will then go further and say, what is hexadecimal for this? We will say we have 1 2 3 4, and there's only 1 there. So this is going to be 1, because I'm going to add 0 here for it to be 2 3 4. I have to add 0. This is 1 F base 16. Okay, so actually our answer in base 16 is what? Is actually 1F. Let me try and bring that a little bit up. Okay, our answer is actually what? Let me not make it that squeezed up. Let's come and try it. Let's redo this. Okay, what we're doing here, remember when with the shortcut method, we actually what? We actually, so what we would do here is we could have, if we're not restricted from doing the shortcut method, we could have said, maybe I should start this on a clear page, and what am I doing? I need to have a page first, and then say, okay, from this page, our question was 27 minus 72, was it? So was it 72? Let me double check. Let me go back and check. 72, yes. 72, what am I doing? 72 in base 8. We could have divided 2 into 27 here and gotten our answer, which we did repeatedly until what? Until we got our 11011 base 2. But for this section here, we could have remembered that we have a shortcut method which says what? Is base 8, so we need 421 for the 7, 421 for the 2. So this could have been 111, and then this would have been 010 base what? Base 2. So if we look there, our previous session there, that was our answer was 1111012, which is what we are having through the what? Through the shortcut method. So let me go back through the shortcut method. So we could have gone straight here and then done our what? Done our math the way we did it. Remember, our answer was 5 ones. Our answer after doing our subtraction, our math was 5 ones, 1 1 1 1 1. Our answer here was 11111 to base 2, but we were asked, this was our answer, we were asked to give this answer in what? In hex. So we could have said 1 times 2 to the power of 0 1 2 3 4 plus 1 times 2 to the power of 3 plus 1 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. Where am I getting it? This is 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0. So I could have then said this is 16 plus 8 plus 4 plus 2 plus, of course, 1. And then our answer here is what? Obviously 33, because 16 and 4, 31, not 33, 31, because 16 and 4 give us 20, 8 and 2 give us 10, 20 and 10 give us 30, plus 1 give us 31. This would have been our answer in what? In this, if the answer was, if we were asked to give the answer in base 10, this would have been our answer. But we were asked to give our answer in what? In hex. So what would have done? We would have said, what is our decimal equivalent in hex? 16 there would have given us what? 1 remainder what? Remainder 15. But remember that 15 is equivalent to what? To F. Okay, then we say 16 there, it would give us what? 0 remainder 1. Okay, so our answer is therefore 27 minus 72 base 8 would have given us in base 16 1, because remember we take it up. This is the most significant digit and this is the LSD, and there's only 2 of them, so our answer is 1F in base 16. Okay, so this would have been our answer, or ultimate answer. But I also want to bring your attention to, if there was no restriction, you could have then said, okay, but what? I already had 1 1 1 1 1 base 2. I could have said, oh, I've got the shortcut method and I can make this 4 and make that, oh, it's a little bit difficult doing it from the left. Make I'm starting to be embarrassed. Make this Oh, that's better. 4 of them. So because remember, the bigger symbols from 8 to 15 need 4 bits. So when you're converting binary straight to hex through the shortcut method, you'd have then said this is what? This is 1, because it's 8, 4, 2, 1. There's only 1. This here is what? Is the equivalent of 8 plus 4 plus 2 plus 1 is 15. So this would have been a 1f to base 16. And this is thanks to the shortcut method. So if there had been no restriction, I think the allocation of marks would actually say if which is the fairer method to use. If the marks suggested that this part probably was 1 or 2 marks, probably you go for the shortcut method. But if I say maybe probably that conversion through the allocation of marks, it seems obvious that probably I allocated, what are we doing? We allocated more marks. We allocated, if it's obvious that we allocated around, say, plus minus 5 to 6 marks for this part alone, then obviously would have been wanting the long method. But it is best practice. It is always going to be mentioned whether you are allowed to use the shortcut method. If it's not shortcut method or not, if it's not mentioned, then you are free to do whichever method, because both methods are actually quite right. So I don't know. This was me trying to give you trying to give you subtraction, and this was subtraction in binary. And then hope this was a useful exercise, and going forward you are able to handle your own examples. All right, with that, time to give you a salute, and later.